as usual, to find the general solution, we know the general form is y equals yc plus yp. So let me continue using the blue marker I'm using because I feel that this might not be very clear to some. So yc plus yp. So as usual, the first thing you do is you find yc. So the first step is you solve for yc, and then we said solving for yc just simply implies solving the associated homogeneous system. That is when the right hand side equals 0. 1 over 4y equals 0. So that's what we have for the first. So the next thing is we want to solve or want to find yp. Now to find yp using the annihilator approach, that's to find a particular integral using the annihilator approach, we need an operator that is going to set the right hand side to 0 when acted upon. So how do we find that? So as usual, what we have in the right hand side is e to the power x into sine of 3x minus cosine of 3x. So we observe that here our m here is, this is 1, and then this is 3, and then this is 3 cosine of 3x. So as usual, we've explained how to find the annihilator operator of a function like this in the past videos. So if you do not know how I got it, you should go and check that how I got it. So anyway, the annihilator of this function here is d squared minus 2d plus 10. So that's the annihilator of this function here. So having known the annihilator operator of the right hand side, I'm going to apply the annihilator to both the left and right hand side of the non-homogeneous differential equation. So and then when we apply that, so we should know that this is what we're using. So let's apply that. What we're going to have is d squared minus 2d plus 10. So it operates on the left hand side, which is d squared instead of y prime prime plus d plus 1 over 4y equals, so we apply it to the right hand side again just to balance the whole stuff, into e to the power x into sine of 3x minus cosine of 3x. So that is what we have, and then this goes to 0 since this annihilates this, we know that already. So what we are left with is d squared minus 2d plus 10 into d squared plus d plus 1 over 4y. So this is what we are left with, equals 0, and then this is a homogeneous system. So to solve this, as usual, we form the auxiliary equation. So we have the auxiliary equation here is going to be m squared minus 2m plus 10 into, so we have m squared plus m then plus 1 all over 4 equals 0. So we need to solve this. So to solve this, so we already know that the solution of, we've already done this earlier on, and then to solve this is it's like a piece of cake. So we have our m1 m2, that's on solving this, to be 1 plus or minus 3i, and then for the other side we have our m3 m4 to be minus half. So this one here has a multiplicity of 2. So based on this result, we could have our solution here to be y equals, so since we have 1 plus or minus 3x, so this is my alpha, this is my beta, so we have e to the power alpha x, which is x, into cosine of 3x plus sine of 3x. So you shouldn't forget to put your c1, your arbitrary constants there, then plus, so we have c3 e to the power minus half x plus c4 x, now e to the power minus half x. So the next thing is we recognize the the complementary function from the solution we got. So this is my complementary function here, and then you observe that this is the complementary function there. So that implies that the remaining term of y is going to be our yp. That is, what we have here is going to be our yp. So now, having known our yp, let's continue solving. I hope you're enjoying it. So this is yp equals e to the power x into c1 cosine of 3x plus c2 sine of 3x. So like I said, I just want to continue, just to be consistent with what I'm doing. I'm going to replace my c1 and my c2 with a and b. So I'm going to say let yp equals e to the power x into a cosine of 3x plus b sine of 3x. So since we want to substitute it into the differential equation, just for justification, then we need to find y prime and y prime prime. So from here, our yp prime equals, is like we're applying product through, so that will be e to the power x into, so we differentiate this and leave this, cosine of 3x plus b sine of 3x, then plus, we leave this and differentiate the other, differentiate this, we have minus 3a sine of 3x plus 3b cosine of 3x. So this is what we have, and then the next thing is we want to find the second derivative of yp. So we differentiate the whole thing again, so that's going to be e to the power x into a cosine of this, so it's like we're leaving this, we're differentiating this, we're leaving this, a cosine of 3x plus b sine of 3x, then plus e to the power x minus 3a sine of 3x plus 3b cosine of 3x. I'm trying to go in baby steps so that we really understand and appreciate the way the whole thing is being achieved. So it's not like there is a walkover through or something, or probably a shortcut. No, there's no shortcut or anything. The main thing is you just try to be very careful when you're trying to solve this little algebraic stuff like that. So e to the power x into minus 3a sine of 3x plus 3b cosine of 3x, then plus e to the power x into minus 9a sine of 3x minus 9b cosine of 3x. So all I just did is just differentiating this whole thing, and then we come here. I believe it should be a piece of cake for us. Anyway, so we substitute yp prime prime, yp prime and yp into the original differential equation, and then when we do that, what we'll obtain is, so let me just say on substitution we obtain, oh, my handwriting there. So what we're going to obtain is minus 9 all over 4. So you should try this out and see that we actually got the same thing. Minus 4b, then cosine of 3x plus 4a plus 3b into sine of 3x, so we can close brackets here, then this equals e to the power x into sine, that's what we have in the right hand side, is e to the power x sine of 3x minus cosine of 3x. So I'm just rewriting that down. So sine of 3x minus cosine of 3x. So this is what we have. So the next thing we want to do is we'll start comparing the coefficients, compare coefficients. So the coefficient of cosine of 3x here is 3a minus 4b, what's the name again? 3a minus 4b and minus 9 over 4. So that's the coefficient of cosine of 3x e to the power x cosine of 3x. That's the coefficient there. So, and then the coefficient of e to the power x sine of 3x here is 1. So we would say minus 9 all over 4 into 3a minus 4b equals 1. So similarly, the coefficient of sine of 3x series of e to the power x sine of 3x is 4a plus 3b times minus 9 over 4, while the coefficient of e to the power x sine of 3x is what we have at the other side here. So I guess we have not missed anything up here. So for cosine of 3x here, the coefficient is minus 9 over 4 this, while for cosine of 3x here, okay, so here should be minus 1. There should be a negative sign here because of a negative sign here. And then for the next one, so the coefficient of sine of 3x e to the power x is minus 9 over 4 times 4a plus 3b, while the coefficient here is 1. So another way of writing this is just by saying 3a, just say 3a, is it what am I writing here? So it should be 3a minus 4b here. 3a minus 4b equals 4 over 9. I'm just cross multiplying here, and then we have 4a plus 3b equals minus 4 all over 9. So anyway, when we solve the simultaneous equation that we have, this simultaneous equation that we have here, so what we have for our a equals minus 4 all over 225, and then our b equals minus 28 all over 225. You could just punch your calculator to just confirm all these answers. So we now have a value for our a, and then we have another value for our b. So and then this is our yp now. So we have a value for a, we've gotten a, and we've gotten b. So we make a substitution immediately. So therefore, our yp there is going to be, that's after making a substitution, would have e to the power x, yeah, I guess that should be correct, then minus 4 all over 225 cosine of 3x minus 28 divided by 225 sine of 3x. Yes, I can remember. So this is what we have for our yp, and then since we obtained this for our yc, that's the complementary function, we obtained this for the complementary function. So the sum of the complementary function and the particular solution gives the general solution. So therefore, the general solution, we're just going to call it gen solution, is y equals our yc, which is c1 e to the power minus x all over 2 plus c2 x e to the power minus x all over 2 plus our yp, which is e to the power x into minus 4 all over 225 cosine of 3x minus 28 divided by 225 sine of 3x. So this is what we have for the general solution of the system I just that we just walked through together, and that completes the problem.